All right, so in this video we're going to continue with our calculator hints, and we're going to focus on the idea of storing values and using your the store button that you have on your calculator, which you're going to see STO. It's right over the on button. So if we go ahead and we look at our calculator, I'm going to move this over so you can see the whole thing. This is the button we're going to start using. Now, this button has so many helpful applications on the test. So let's go ahead and just look at how we're going to use it. So in this first example, notice here I have an x and a y, and we want to know which expression is equivalent to this. So the great thing is we have a built-in x button, right? So this button is fine, but if you notice, we don't have a built-in variable button for the y. But this alpha, if you look over your calculator, there's all these green letters, and you can actually start storing for alpha y, all right? Now, where that's going to be helpful is let's go ahead and just store a 10 for x, because this problem gives me an x and a y. And let's store a 10 for y. And so we're going to use that alpha button. Now, the wonderful thing about this is now every problem, or every part of this problem I work through, the calculator is going to keep this 10 stored for x and the 10 stored for y. The one thing, this does not mess up anything you do with graphing, so don't let that bother you. But what I get to do now is I get to put in a square root of 20x squared, or sorry, x to the 16th. Oof, okay, 20 x to the 16th. And then I'm going to arrow over, because I don't want it to stay in the exponent, but don't arrow out of our radical, alpha y square root 25. So we're going to get some weird number, right? Because I plugged in a 10 for the x and a 10 for the y, but I can see here that we should get a 1.41 e to the 21st, okay? So that means times 10 to the 21st power. Well, let's see if this option A gives me the exact same thing. So 2x to the 4th, arrow over, so it leaves the exponent, alpha y to the 5th, and now I need to put in a square root, so seconds radical 5. That doesn't match. A is not the correct answer, all right? Now, since we've already kind of typed in some of this stuff, you can arrow up, and if you hit enter, it brings it down. Now I get to just change around these terms. So I'm going to arrow over, and I'm going to change the 2 to a 5. The variables stay the same, and I'm going to change the radical to a 2, a square root of 2. Hit enter, and B is out, because remember, we're looking for this 1.41 times 10 to the 21st. All right, so now I'm going to type in, I'm going to go up, I'm going to hit enter, I'm going to change the 2 back. The variable with the x, or sorry, the exponent with the x is now an 8, and the exponent with the y is a 12. And then with the radical, we have a 5 and alpha y. And there is the answer that works. All right, now, it never hurts to just check this one also, but if you plug this one in, it's not going to work. So without doing any math and only using the store function on my calculator, I just figured out that the correct answer is C. All right, now, if you look here on this page, this is a radical example. This is another radical example. This has rationals, and this is factoring. All of these problems you can do using this method. So I'm going to leave the radical one for you to try, all right, because it's the same thing. But I want to just go over typing in this one, because look at all these fractions we have. So I'm going to clear this out. Just for the fun of it, I'm going to store for x again, all right? I always use 10. You can use anything. Just don't use a 1 or a 0. Just keep it easy on yourself. So let's just stick with a 10. And then here, I have W's in the problem, but since I have this nice X button ready to go, I'm just going to use that. Now, alpha y equals, I have this fraction bar hiding. And if you guys notice here, I have a fraction over a fraction. So I'm going to go ahead and I'm going to hit alpha y equals again, so I can type in the top fraction, which is an 11 minus x over a 30x squared. And then in the denominator, I have alpha y equals again, because I'm putting in a whole nother fraction in the denominator, x minus 11 over 5x to the 6th power. All right, and I get this number. Now remember, that's because I stored a 10. So that number is just what I'm going to look for as I plug in these choices. So when I go back, now I'm going to try answer A. So I'm going to alpha y equals negative x to the 4th divided by 6. And there's the answer. So it's always nice when the first one actually works. Again, you have unlimited time on your SOL. So don't forget that you could actually go and plug them all in and just make sure that those work. So now those matched. The answer is A. All right. And then same deal here. You could store, right? And you just type them in. So just because I'm going to store again, all right, I like to use 10. We're going to type in 18x to the 4th plus, oops, forgot my plus, plus 12x to the 3rd minus 6x, and you're going to get a number, and then we're going to compare them. So if you typed in the 6x to the 3rd with a parenthesis, 3x plus 2, and you hit enter, it's going to give you a wrong answer. They're close, but that is not right. If I go ahead and I'm just going to type in this last one, because I have a sneaking suspicion of what the correct answer is, 6x times 3x to the 3rd plus 2x squared minus a 1, and there's our matching numbers. So this is such a helpful technique for simplifying. You just want to find the ones that match. All right. Now, sometimes they're going to give you 2 that match because this says completely factored. So you have to be really careful that if 2 match, that you answer with the one that's factored the most, all right, with the most terms taken out. All right, the other place where we're going to want to be using this store function on our calculator is when we have to solve, all right? Now, if I'm going to go ahead and solve, and let's go ahead and start with, oh, we've got lots of options here. Let's go ahead and start with this one, all right? Well, here, if I want to know if a 27 over 14 is the correct answer to this problem, then one option we could do is store that x value. All right, and I'm actually in the next video when we do solving, I'm going to show you another method we could use for this one also. But if I go ahead and I want to say, I'm going to clear all this out. All right, there we go. I'm going to say 27 over 14 and store for the x. And it's going to tell me that my x is now 1.9. Well, I want to see if these two sides actually end up equaling each other. So I would go ahead and I would use that same alpha y equals to get the fraction, and I would type in an x plus 2 over x plus alpha y equals x minus 6, and I'm going to show you, you're only going to have to type each of these in one time. All right, and I get that that side is a 1.33. So let's go ahead and try the other side. Alpha y equals, if 27 over 14 is a solution, then I'm going to get the exact same number here. 2x plus 9 over 5x, hit enter, and this one worked. All right, so we have an answer, which is the top one. Let me show you how we could store a 17 over 14 and save ourselves just a little bit of time. So if I go ahead and I store, let's say there maybe is a chance of 2 solutions. So 17 over 14, this is multiple choice, so we know we're done. I just want to show you a shortcut. Now my calculator is thinking of a 1.21. It has a new x value stored in. So instead of retyping that whole equation, arrow up and hit enter, and then hit enter again, and your calculator has substituted the x value. Do the same thing, arrow up, hit enter, and then you'll notice here, these don't match, which just supports our point that when I plugged in a 17 over 14, it didn't work. So just to summarize here, the correct answer is definitely A, because our calculator showed us that. B doesn't work. If you went through and tried these, you would see C and D also don't work.